Okay, problem number one off the sheet. Now, remember what I said about multiplying radicals. It's very simple. You multiply the numbers on the outside, you multiply the numbers on the inside. If there's no number, you can put a 1. You don't have to. Now, so here when you multiply radical 2 times 4, this is not radical 8. This is not in the jail, and he's not going in there no matter how nicely you ask him. So you have to do 1 times 4 on the outside, and the radical 2 just goes along for the ride. There's nothing you can do. It's, it's like if you're doing x times 4, you have to write 4x. So now you want to do radical 2 times radical 3. Again, you can put a 1 there if you want. On the outside, you have 1 times 1, pow, 1, but you don't have to write the 1. And then you do radical 2 times radical 3, which makes radical 6. You multiply the numbers on the inside. It's that easy. Doesn't break down, doesn't break down. Can't combine. This isn't radical 8. These are not like creatures. If you had 4x plus y, wait, y, you can't add these together. These are different creatures. Radical 2 and radical 6 are not the same creatures, so you can't combine them. You have no choice but to stop. All right, problem number 2. Pretty simple. Again, put a 1 if you need to. Multiply the numbers on the outside. 5 times 1, 5. Multiply the numbers on the inside. Radical 7 and radical 2 is 14. Minus, again, you have a 1 there. 1 times 1 is 1. Radical 7 and radical 3 make radical 21. Now, this is the part where, you got to think a little. 14 and 21 don't break down any further. I mean, you just did 7 times 2 and 7 times 3. There's no point in you splitting them up. You can't write 14 as any of the perfect squares. So you stop. These aren't the same radical. This isn't radical 14, so you can't combine them. There's nothing left to do. It's that simple. The problem is that easy. All right, the third one. Finally, a challenging one. Okay, so multiply the first. 1 times 2, 2. Radical 3 and radical 3 make radical 9. Now, if you want, you can do radical 3 times radical 3 makes 3. It's the same difference. But I'm going to write it all out. 1 times 1 is 1. Radical 3 and radical 8 make radical 24. Now, here's where you actually have some work to do. Radical 9 comes out of jail, right? It's a perfect square. 1, 2, 3. So free him from the jail. Take him out. 24 breaks down. You can write 24. You look at the list. Not 16, not 9. Aha, 4. You can write 24 as 4 times 6. This is why we did this. This is lesson 1. We did that first. On the outside here, you get 2 times 3, which is 6. Radical 4 comes out of jail as 2. This radical 6 goes along for the ride. The easiest mistake to make is to do 6 plus 2 and put 8. But, if you had $6, and 2 apples, you can't tell me this is 8 apples, right? These are not the same creature. This is $6, 6. This is 2 radical 6s. These are not like terms, so you can't put them together no matter how badly you may want to. You got to stop right there, all right? They don't combine. So don't make this mistake and make them 8. All right, the fourth one. Again, a little bit tricky, so you have to be careful. You're going to do radical 2 times radical 8, which is radical 16, right? In the front, you have a 1 and a 1, so there's a 1 in front. And then over here, you're going to have negative 4 times 1. And then radical 2 and radical 5, when you multiply them, make radical 10. Now, you would think it's over. It's almost over. The problem is 16. Look, there's 16. 1, 2, 3, 4. This is a perfect square. Now, you don't want to split 16 up, right? You don't want to do 8 and 2, 4 and 4. And then you can say, 4 and 4. You don't need to split 16 up. He is on your release list. Take him directly out of jail. He is due to get out. Release him. Now, you have minus 4 radical 10. Whoa. You're like, 4 minus 4 is 0. This makes no sense whatsoever. Again, if you had 4 minus 4x, you can't combine these. These are not like terms. You have $4 and you have 4 radical 10s. There's nothing you can do about it except to leave it alone. So you have to stop here. Even though this answer looks kind of funky, ain't nothing you can do with it. Just got to leave it. All right, number 5. Also a good one. Gotta be careful with it again. You have a 1. Multiply 1 times 5 is 5 on the outside of the jail. Radical 10 and radical 3, when you times them, you do 10 times 3, get 30. Plus, now what are we going to have? 1 times 3 is 3. Whoops. This is supposed to be 2. Radical 10 times radical 2 is radical 20. I was getting ahead of myself there. I'm not going to give you 10 times 20. So that's my fault. I copied it wrong. All right. So now, radical 30, this is where you have to be really careful and pay attention. 30 doesn't break down with any of these numbers. 30 is not divisible by 25. It's not divisible by 16. 30 is not divisible by 9, and it's not divisible by 4. So there's nothing you can do with 30. Leave it alone. You're like, oh, I'm going to write it as 5 times 6. For what purpose? There's no reason to write it as smaller numbers unless you can take one out of jail. Now, 20, on the other hand, 20 is divisible by 4. So you want to split it up with 4 and 5. 5 radical 30. You are stuck with this. There's nothing you can do but leave it there. But the 4 comes out of jail, right? Perfect square. So free him from the jail. And now he's going to hook up with his buddy, the 3, that's already out there waiting. So you get 5 radical 30. That has stayed the whole time. It doesn't change. Here you have to do 3 times 2 to make 6 on the outside, and then you get a 5. Don't get cute and think, oh, 5 plus 6 is 11. 30 plus 5 is 35. It doesn't work that way. These are different radicals. You cannot ever add them together. If this was radical 5 and this was radical 5, you could combine them, but I can't. So I'm done. I stop. All right. I broke down the radical that does break down. I left the other one alone. It doesn't break down using a perfect square. All right. That's it.